yesterday we had highlighted a few things. We had highlighted arithmetic sequence, common difference, and D. And we were looking at this sequence that was going up by 3. Use the book as well, for sure. And on the activity that we did before this lesson, we saw that if you added the same amount each time, it ended up making a graph that's a straight line. And we even made a table of values, and in this table of values, we have the term number and the term value, and the first term is 4, the second term is 7, the third one is 10, the fourth one is 13, and so on. And one of the things that we made a connection of is that if this is going up by 3 each time, and this is going up by 1 each time, that makes this have a slope of 3. And then we said, hey, if it has a slope of 3, I know from y equals mx plus b, that's what my lines are. I know that it's going to be 3x, and then we used the numbers to figure out the b value, right? We just like plugged 1 in. If you choose the second term, if I plug in 2, 3 times 2 is 6. What do I want to get? I want to get 7. So what would I have to do to this? I'd have to add 1. And that makes the formula. You could have probably also gone back here and said, if I go down 3 and over 1 more time, I can actually see that my y-intercept should be 1, connecting us to y equals mx plus b. Now, the difference between a line and a sequence is a sequence is only the dots, whereas a line has everything included in between. Like, in the line, you're allowed to plug in 2.2, but there is no term 2.2. So our notation changes a little bit when we talk about sequences. So instead of using y for the term value, we use term with a little n. It could be term like 4 is term 1, 7 is term 2, 10 is term 3, 14 is term 4. We write the little number underneath it to say where it is its position in the sequence. So we use Tn to say any term. And you'll sometimes see this referred to as any term in general, so they call it the general term. And the formula would be 3n plus 1. So that's where we were yesterday, and now we're ready to go to our first example, example 1. And this question is asking us to find the first 6 terms of an increasing arithmetic sequence. So we've got some important words here. Increasing means that it goes up by 1. So this is going to be on page 4. And on page 4, all of these examples, they have the example at the top, and then they have space where you can write the work underneath. So we want an increasing arithmetic sequence. And if it tells you that it's arithmetic, that means there's a common difference. You are always adding the same thing each time. So this question is wide open. There's a lot of different answers. First of all, you need a starting point. Nicholas, pick a favorite number. 8. Okay, so in part A, we could start with 8. Then we need a common difference. What should we add each time? Abby, pick another favorite number. 2. So if we added 2, we would get 10. Then 12. We need 6 of them. Okay, there we go. Can you see that your common difference, we're adding 2, so your D value would be 2. This makes it an arithmetic sequence. Second one, we need one that's decreasing. Audrey, favorite number? 4. Okay, and let's see. Grayson, what should we go down by? Going to go down by 3. So if I go down by 3, that makes my common difference minus 3. Minus 2, minus 5, minus 8, minus 11, and when we're going down, our common difference would be a negative number, because we're going down by 3 times. Oh, and thanks a lot. I really appreciate it. You guys could have made my life terrible. Like, Grayson could have said, oh, favorite number? I'd like to start with 37.825, right? And then what are we going to go down by each time? Oh, let's go down by 2.32. Really make the mental math terrible, right? Have to pull out our calculator. So this was nice, okay? So what's going to happen is every example that we have, we're going to make a video for it. You're going to write the notes down beside. The textbook also has an example that's similar to this written out. But by doing one together, you guys sort of get an idea of like what kind of work would I need to show if a question like this showed up on a quiz or a test. And then after we're done a question, what I'm going to do is I'm going to tell you to circle, and in this case, we're going to turn to the exercises, which start after the lesson. So if you turn to page 8, circle questions 4, 5, and 7. Sometimes people like to write above example 1, 4, 5, and 7 as well, sort of a reminder that after we did example 1, I should be able to do homework questions 4, 5, and 7. Okay? I also want you to know that in this book, which is nicer than most math textbooks, okay, there's space. First of all, you can do all of your answers for 4, 5, and 7 right in here, which is really nice. Then, usually in a math book, where do you have to go to find the answers? The very end. Someone was like, that's annoying. Why is that annoying? Because not only have to go to the very end, it's like hard to find which page was it, blah, blah, all the answers are together. So this textbook was smart, and they just said, well, once the homework is done on page 13, there's the answers for the homework right away. So really nice because you can check your answers, and your answers are just 2 pages later on page 13. Now, sometimes I'm going to give you time right after to start your homework. Today we're going to do example 1 and example 2, and then I'll give you some time to practice some of those questions. Then we'll do questions 3 and 4, and then have some time to practice some of those questions, and you can ask questions right away, which is really nice. But before we get to example 2, I want you to turn to or just go back to example 1 at the bottom of the page on page 4. Pull out your highlighter again, and they have this idea of getting the general term or the formula for the general term. So when we did our activity to begin with, I showed you sort of 2 different patterns. They have one of the patterns here. We're going to look at that one first. We're saying if we had this sequence, 3, 7, 11, 15, 19, I notice that I'm adding by 4 each time. So my common difference is 4. And if I wanted to get to term 2, I would start with term 1, which is 3, and I'd have to add 4 ones. If I started at term 1, I could start with term 1, and it's kind of Not necessarily, but you could say you didn't have to add 4 at all, because you were starting at term 1. If I wanted to get to term 3, then I would start at term 1, and I would have to add 4 2 times. And then they continue and extend this until you get to Tn. And what I would like us to do is before we get to Tn, so in this dot 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 space, I'd like you to put T100. What's T100 going to look like? Do you recognize the pattern that's happening? The pattern that's happening says if I wanted to get to T100, I would have to start at term 1, and then I'm going to add the common difference of 4 a certain amount of times. How many times would you have to add 4 to 3 to get to term 100? 99. And by doing term 100, we get to see this pattern pretty easily. Do you see that the pattern is that you're always adding the common difference 1 less than what you want to find? If you wanted to find term 4, you only had to add the common difference 3 times. So if you want to find 100, you're going to have to start with term 1 and add the common difference 1 less than 100. If you see it with 100, when you choose n, does it make sense that this has to be 1 less than n? If you're finding any term, that's what term n says, a general one. Again, we're starting with term 1, and then we have our common difference 1 less than n. So they're pointing things out in your notes. The general term is always the first term plus the common difference, and then it's 1 less. We put that arrow for this one too. That's 1 less than n. Now, we knew what the sequence was. We knew what term 1 was 3. We knew that the common difference was 4. Does it make sense that this will be true even if I changed term 1 to something else? Does it make sense that this will be true even if I change the common difference to a different number? And this is how mathematicians make a formula. They say, you can make the formula, it's Tn. The first term, I'll just write T1, because whatever sequence I have, if it's an arithmetic sequence, that's where my term 1 will go. Plus, my common difference, I'm going to use the letter D, and minus 1. And they have this, your first formula, right here on the top of page 5 on your formula sheet. So this is how a formula gets made. We look at a pattern, we look at what stays the same, and then it's sort of like, oh, this is what's always happening, so now I can make a formula. Okay. Now, sometimes I'm going to write off to the side here. I also showed you guys a shortcut. Sometimes you're going to like the shortcut. Some of you are going to like the formula all the time. What did we do with our shortcut? We looked at our first 3 terms, 4 terms, doesn't matter how many. You knew that your common difference made a line, y equals mx plus b. And if your common difference was plus 4, it would have to be a 4x. And then we said, well, what would make it work? Right? You can plug in any one of these numbers. If you plugged in the 3, what's 4 times 3? 12. I want 11. What makes it work? Minus 1. Do you see, I change this to Tn, 4n minus 1, that's the shortcut now. Can you see that this and you see that those two are the same. How are they the same? Well, if I distributed this 4n, this 4 to this, and this 4 to this, I would get the 4n. Matches up perfectly. And then I have a plus 3, and then I would have a minus 4, which are like terms. What's 3 minus 4? Minus 1. So sometimes you might want to use the shortcut. Sometimes you might want to use the formula. That's up